So we're going to do absolute value equations and inequalities today. And what I do is I do a different method than most people. And because normally you have your book to refer to, and I would just rather give you an optional way that is actually more general, and I think is helpful. So one of the first things we need to talk about is the definition. So the definition is following. Absolute value of y is, it's either y if y is greater than or equal to 0, and it's negative y if y is less than 0. So for example, if you have absolute value of 4 is greater than 0, greater than or equal to 0. So this right here, this part applies. And so the answer is just 4. You just pull out the y, 4. Okay. Now, if you have negative 4, on the other hand, okay, negative 4, then negative 4 is according to this rule. So you put a negative on the negative 4. In this case, y is negative 4 in this case. So you put a negative on the negative 4, and you get positive 4. Okay. This is what you're used to. If you have a negative number, you just make it positive. And if the number is already positive, you keep it positive. Okay. Now, one of the graphical, the geometric way of looking at this is the absolute value of y is its distance from the origin. And that's true. That's another way to look at it. Okay. So when you consider the number 4, okay, 4, I'm sorry, 0. Let me look at 0 first. 0. Negative 4 is here, and 4 is to the right of 0. And so negative 4 is 4 units from the origin, and so is 4. 4 is 4 units from the origin. So the absolute value of negative 4 will be 4 because its distance from the origin is 4. And also the absolute value of 4 is also 4 because its distance from the origin is 4. Okay? So that's a couple of ways to look at absolute value. Now, whenever you have an equation, though, all right, so for example, if you have like a 2x minus 3 is equal to 5, all right, this goes according to the definition as well. 2x minus 3 is equal to positive 2x minus 3, or it's equal to negative 2x minus 3. Okay, this is if 2x minus 3 is greater than or equal to 0, and this is if 2x minus 3 is less than 0. Now, this piece right here, you don't have to worry about right now. Basically, what you do, well, I need to put parentheses around this. Basically, what you do is you pull out 2x minus 3 as positive here, and then as negative here. Okay, so it's one or the other. Okay, so what I'm going to do is there's two cases. Case 1, this is case 1 here, and this is case 2 here. Case 1 says 2x minus 3 is positive, and that's equal to 5. And case 2 says 2x minus 3 with a negative on it is equal to 5. Okay. Now on the one on the right here, we can multiply both sides by a negative and make this 2x minus 3 equals 5. So what you have you have two equations. You have this one on the left and this one on the right. And this is normally where a book that you're reading may start the problem. Okay. The reason I don't do it that way, I use case 1 and I use case 2, is going to become apparent in a little bit. All right. Okay, so let's continue this problem and solve both sides. So I'm going to add 3 to both sides. And over here, I'm going to add 3 to both sides. And on the left, I get 2x equals 8. And on the right, I get 2x equals negative 2. This is -2. So now what I do is I'm going to divide by 2 on this side, and I'm going to divide by 2 on this side. And on the left, I get x equals 4, and on the right, I get x equals -1. And those are the two answers, 4 and -1. So apparently, 2x minus 3 is, if it's equal to 5, okay, x can be 4 or -1. So let's check this. Let's do a little check. Absolute value of 2x minus 3 is equal to 5. Let's plug in 4 for x. 2 times 4 minus 3. Absolute value equals 5. This is inside, this is 8. 8 minus 3, absolute value, which is absolute value of 5, which is 5. Yeah, so it checks out. Now on the other side, we're going to check this one as well. So I take 2x minus 3 equals 5. I'm going to plug in -1. Minus 3 is equal to 5. 2 times -1 is -2. Minus 3 is equal to 5. Absolute value. Absolute value of -5 equals 5. Yeah, that's true, because 5 equals 5. Absolute value of -5 is 5. So this works out. So our answers are 4 and -1. And so we're going to put that in the proper notation. Answer is, we're going to use these brackets, 4 and -1. It doesn't matter what order you put them in. There you go. You have to use these brackets. Don't use these brackets, and don't use these brackets or any combination of those. Those are going to be reserved for interval notation. Okay, so this is interval notation. All right, so now what about inequalities? Okay, so let's look at inequalities. So I'm going to take them 2 steps at a time, 1 step at a time, excuse me. So let's look at this version and this version. So less than and less than or equal to. So let me give you an example. So let's just do the 2x minus. Let's do 2x plus 7 is less than or equal to. Let's make it 9. Okay. So case 1, same thing. 2x plus 7 is less than or equal to 9. In case 2, 2x plus 7 with a negative on it. Is less than or equal to 9. So we solved these the same as before. So I'm going to multiply both sides by a negative on the right, excuse me. So it becomes 2x plus 7 greater than or equal to -9. Remember, when you multiply by a negative, the inequality sign switches, okay? So then we're going to add 7, subtract 7 from both sides over here. Oh, before we do that, let me just point something out. This step right here, this along with this is where you would see in the book. That's how the book does it, okay? And they have their reasons for doing it, and that's great. I just like to do it a different way, so that you have 2 ways to solve it if you don't understand one way. If you don't understand my way, just do it the way the book does it. So I'm going to subtract 7, and so we get 2x is greater than or equal to -16, and then we're going to divide by 2 on both sides here, and we get x is greater than or equal to -8. A hard time drawing 8s on this tablet. All right, now let's look at the other one. The other one, I'm going to subtract 7, and I get 2x less than or equal to 2. And now when I divide by 2 on both sides, now remember, only if I'm divided by a negative does that inequality sign switch, so I'm going to keep it the same. X less than or equal to 1. Okay, so now whenever I deal with it less than or equal to, I take the union, I take the intersection of both cases. Intersection of both cases. So what I do down here is I'm going to graph each one on a number line. So here's a number line. I'm just going to put the numbers, not 0. 0 won't matter in this case. So x is greater than or equal to 1. I'll do that in red. Greater than or equal to. I'm sorry, less than or equal to 1. It's less than or equal to 1. So that's this right here, all the way down to negative infinity. And then the other one I'll do in green. X is greater than or equal to negative 8, so closing the dot. Greater than or equal to negative 8, all the way up to positive infinity. And so the intersection is right here in between them. So I get negative 8 with a bracket, 1 with a bracket, because it's solid dots. Solid dots. So we use brackets for that, not parentheses, brackets, because you're including the numbers. Okay, and that's the answer. Okay, so the rule is this. So for less than and less than or equal to absolute value inequalities, what you do is, the first thing you do is split up into two cases. And solve. Then the second thing you do, solve. The second thing you do is you graph both answers on a number line. And then the third thing you do is you take the intersection. Take intersection of both of the two. And that's it. That's how you solve it. All right, so now I'm going to look at inequalities of the form greater than and greater than or equal to. Okay, so let me give you an example. You do the same business, the same stuff. So let's do the absolute value of 3x minus 2 is greater than, let's do greater than this time, greater than, let's say, 7. So case 1, 3x minus 2 is greater than 7. In case 2, negative 3x minus 2 is greater than 7. Okay, so what I'm going to do on the right is I'm going to multiply both sides by a negative. That flips the inequality sign, and I get 3x minus 2 is less than negative 7. Now, this here, along with this, is what you would see in the book. Okay, that's where they would start this problem. Okay, good for them. So what I'm going to do is I'm going to continue on. Let's go over here. So I'm going to add 2 to both sides to solve this. So I get 3x greater than 9. Now I'm going to divide by 3. And I get x is greater than 6. All right, now on the other side, I'm going to add 2, and I get 3x is less than negative 5. And now I'm going to divide by 3 on both sides. By 3, I get x is less than negative 5/3. We'll just leave it like that. You don't need to write it as 1 2/3 negative. You don't need to do that. Okay, just leave it as negative 5/3. Okay, now the same process as last time. So I'm going to graph both on a number line. Negative 5/3 is somewhere over here. Notice I don't care where it is. It's somewhere over there. I know that 0 is in here somewhere. Okay, you don't have to be precise on this. Okay, so now I graph them both. So I'm going to graph x greater than 6 over here in red. That goes all the way to infinity. And then in green, I'm going to graph x less than or equal to negative 5/3. I'm sorry, less than. It's open dots because it's less than, not less than, not less than or equal to, and greater than, not greater than or equal to. So x less than negative 5/3 is all the numbers less to the left of 5/3, and we get negative infinity there. Okay, now what you do, the next step is you take the union of both cases. All right, so the union is all of them together. So if we're using interval notation, we would get negative infinity, which always has a parenthesis, comma, negative 5/3, and then parentheses, union, and then 6 to infinity. And you're done. That's the answer. Okay. All right. So it's the same process as before with the other kind of inequalities and equals. Let's see what we did. So we had 2x minus 3 equals 5. We did case 1, case 2, got the answer, done. Inequalities of less than or equal to version. We did case 1, case 2, graphed them on a number line, took the intersection. Okay? All right, next type, inequalities of greater than or equal to. You did case 1, case 2, graphed them on a number line, and we took the union. Okay? So let me write down the fact. So for inequalities of the form greater than or equal to, first step is split into two cases and solve. Step 2, graph both answers on a number line. And step 3, take the union of both cases. The union is both of them together, like the union of the states is all the states together of both cases. Now, you run into issues with some certain examples, okay? So special cases. These are the problem children, special cases. One special case would be following: absolute value, let's say, of 4x plus 1 is equal to -3. Okay, this can't happen. This one's no solution since an absolute value of something is always positive, and -3 is negative. Okay, so this is no solution. Okay. The second kind that you'll run into is something like, I don't know, 5x minus 2 is less than -2. All right. Well, let's make it -12. Okay, so it's not the -2 here. Now, this is also no solution. No solution for the same reason, because the left-hand side, this is positive, and the right-hand side, this is negative, and a positive can't be less than a negative. Okay, we're using less than here. All right, so what if you don't notice it on the test, though? Okay, well, you would just do the same stuff we did before with the cases. You do case 1, 5x minus 2 is less than -12, and then case 2, -5x minus 2 is less than -12. Okay, I'm showing you that you can basically multiply. You can basically do it the same way every time. You don't have to even look out for these crazy cases. So I'm going to add 2 to both sides. Add 2, and I get 5x is less than 14. So x is less than 14 over 5. I think I did that right. Let's see, -12, +12, add 2, 14. Yeah, that's right. Okay, now over here, I'm going to add 2 to both sides. And I get 5x is less than -10. Now I divide by 5 on both sides. And I get x is less than -2. All right. So now we're going to graph both. And now inequality of the less than type, it means intersection. Okay, we're going to take the intersection of both. Okay, so when we get there, we'll see what happens. Here's -2. Here's, oh wait, hang on. This had to be greater than because we divided by a negative. Nope, less than. Oh wait, slight mistake up here. This from this step right here to this step right here, we should have switched the negative sign because we multiply both sides by a negative. So let's do that. This has to be a greater than. Oops, let me get the right color. This has to be a greater than sign. And then this is a greater than sign, and this is a greater than sign here. Okay, so now we're at x is less than 2. We'll do that in green, all the way down to negative infinity. And then in red, I'll do x is greater than 14 over 5. Here's 14 over 5. So greater than 14 over 5 is over here, all the way to infinity. Okay, so I did the left one in green and the right one in red. Now we have to take the intersection, right? Take the intersection, but there is no intersection. They don't intersect at all. There's no common values, okay? No common values or interval. So it's no solution. So this implies then no solution. Now, this is a long way to do a problem that it was kind of obvious at first, if you noticed it. You know, a positive number can't be less than a negative number. But if you don't realize that, if you don't get straight to no solution, and you're just going to walk through the problem like we did before, then you really don't have that. You have to you'll have to see it whenever you get to the end. So the third case is the following. It would be something like x plus 3 is greater than negative 4. Okay. Now, a positive number here, this is always positive, because the absolute value is always positive, is always greater than a negative number. Okay, this is always true, always true. So it's always true, which means that, so it works. So I'm sorry, let me say it better. So any number would work. Any number will solve this inequality. Since any number will solve it, you can look anywhere on the number line, and any number will do it. All of them. Any number will solve it from negative infinity to positive infinity. So your answer is negative infinity to positive infinity using parentheses, since infinity always takes parentheses. You never get to infinity, so you can't include it. Okay, so what if you didn't see that? Well, what you could do is you could just do case 1. What was the problem? You could do case 1, x plus 3 greater than negative 4. Case 2, negative x plus 3 is greater than negative 4. So when you multiply both sides by a negative over here on the right, this is case 2, on the right, just flip the inequality sign. And then when you subtract 3 from both sides, you get x is less than 1. Over here, when you subtract 3 from both sides, you get x is greater than negative 7. Subtract 3, subtract 3, subtract 3, subtract 3. Okay, so now let's graph both on a number line. Here's negative 7, and here's 1. Okay, so I'm going to do the x is greater than negative 7. I'm going to do that in green. This goes all the way to infinity. And then in red, I'll do the x less than 1. So open dot, less than 1. Okay, all the way to negative infinity. Now, with inequalities of the greater than type, let's go back up. Of the greater than type, you take the union of both cases. Okay, so when we go back up, go back down, excuse me, the union of all of them is of the two cases is the whole thing. It's the two cases together, so it's the whole thing. So your answer is negative infinity to positive infinity, which is the same thing we got before, just noticing what was going on immediately. But if you don't notice this piece right here, that you've got an absolute value greater than a negative number, which is always true, if you don't notice that right away, then you would just walk through the same business that we did before. Case 1, case 2, and then graph it. It's one case to graph it, and then figure out union or intersection. Intersection if it's less than or less than or equal to. And so there you go. So that's it. That's how you do absolute value inequalities, the way that I like to teach them.